Let's take a look at some comparison theorems. First, if we have a function f that is greater than or equal to 0 over an interval from a to b, then the integral of f from a to b is greater than or equal to 0. Next, instead of comparing a function to 0, we're comparing it to another function. So, if f is greater than or equal to g on an interval from a to b, then the integral of f from a to b is greater than or equal to the integral of g from a to b. Lastly, if a function f lies between two values on an interval from a to b, then the integral of f lies between those values multiplied by b minus a. Let's look at an example of the comparison properties of integrals. We want to find the minimum and maximum possible values of the integral of sine x from 0 to pi. So let's first draw a picture of the graph to help us see what's going on. The integral is equal to the area of the shaded region in the graph. Let's determine the values of a and b. Recall that a is the lower limit in the integral and b is the upper limit. Using the given information, we know that a equals 0 and b equals pi. Next, we want to determine the minimum and maximum values of f. Notice that on the given interval, the smallest f will ever be is 0, and the greatest it will ever be is 1. So we'll set little m equal to 0 and big M equal to 1. Now recall the comparison theorem, which states that if f is between little m and big M on an interval from a to b, then the integral of f from a to b is between little m times b minus a and big M times b minus a. Let's substitute our known values into this inequality. So we have 0 times pi minus 0 is less than or equal to the integral of sine x dx from 0 to pi, which is less than or equal to 1 times pi minus 0. Simplifying, we find that the integral of sine x dx is between 0 and pi. Let's look at another example. Here, we want to determine which area is greater, the area between f of x and the x-axis, or the area between g of x and the x-axis. To compare the two functions over this interval, we need to graph them on the same coordinate axis. Notice that on the interval from 1 to 4, the curve of f of x lies between the curve of g of x and the x-axis. This means that f of x is less than or equal to g of x over the given interval. From this, we can use the comparison theorem. That tells us that the integral of f of x dx from 1 to 4 is less than or equal to the integral of g of x dx from 1 to 4. Recall that the integral of a function over an interval represents the area between the curve of that function and the x-axis over the interval. Therefore, by the comparison theorem, the area between g of x and the x-axis is greater than the area between f of x and the x-axis on the interval from 1 to 4.